All right, so test 3. You guys cover chapter 4, chapter 5. Chapter 4 is about rationals. Chapter 5 is all about radicals. So let's go ahead and start hitting this stuff up. So you're going to want to, I know for this test, you're going to want to make sure, be on top of that factoring, because that's what's really going to slow you down if you struggle with that factoring. So make sure that you're on top of that. So first things first, basically all this stuff is going to hit you in the order that you kind of learned it. So you learned about domains of rationals first. So how do we find the domain of a rational? What do we got to do? How do we find the domain of a rational? We are going to be looking for real numbers, absolutely. Equal who to 0? Yeah, remember we want to set this denominator equal to 0 because we want to find out those numbers that we want to kick out because they create problems for us when our denominator is 0 because we can't divide by 0. So you just take your denominator, set it equal to 0, x minus 7 equal to 0, and solve. So how do I get the x by itself? Yeah. Plus 7, x is equal to 7. Now, this is the number that creates the problem. This is what we want to throw out. And the information up above says that this needs to be in interval notation. So how do I write the interval notation for this? No, that's set notation. So if we were talking set notation is the pretty easy one for this. I'm going to show it anyway because it's always good to review that. Set notation is with your braces, and then all you do is you write this inside and do what to it? Yeah, there's your set notation. But we want interval notation. Say it again? Not 0. What do you? Yeah, we're going to start with an infinity. What kind of infinity? Negative. And what's in front of it here? A parenthesis, because your infinities always get parentheses. So you can think of your interval notation as your number line. Tell me all the numbers we're inviting. So we start at negative infinity, and we go up to where? 7. Bracket or parenthesis? Parenthesis, because we don't like it. Remember, that's our bad number. We want to jump over that number. So what's the next symbol? A union. Then what? Pick up at 7 again, bracket or parenthesis. And we go to where? There you go. There's your interval notation. Again, this part that you see right here is like us jumping over the 7. Okay, because we don't like the 7. We like everybody else but 7. So there's your interval notation right there from parenthesis negative infinity to 7, parenthesis union, parenthesis 7 to positive infinity, parenthesis. Okay? Question 2, we're going to hit you up with it again. Find us the domain. And again, we want to do interval notation. So how do we find domain again? Who? Set the denominator equal to 0. Perfect. Slide this down some. So we're going to take this denominator, set it equal to 0. Now what? Factor. That's what I said. Stay on top of that factoring. Because these beginning problems are going to hit you up with factoring after factoring after factoring. So the question is, how does this factor? Also, the other good thing about the factoring is we're going to make the factoring pretty easy for you guys on here. Say it again? Yeah. We're going to try and keep the a, remember the number in front of x squared right here? We're going to try and keep it 1 for almost all of your problems. There's one where it's not, but that's all right. So, what do we do? How do we factor that bad boy? Uh-huh. That's right. Find a number, or find two numbers that when multiplied give you negative 54, but when you add them, get you a negative 3. Anybody know what those two numbers are? 6 and 9. Good. I like the 6 and I like the 9. A negative 9, positive 6. Because when you multiply those, you get the negative 54. When you add those, you get the negative 3. And there should just be an X in front of all that. Good. So now that it's factored, what do we do now? That's right. Take your two parentheses, set them both equal to 0. That's our zero product rule at work. And now we can solve. What will X equal right here? 9. That's right, because you add 9 to both sides. What will X equal on this one? Perfect. Now that you have all your information, we can write our domain. And again, it wants interval. So you don't have to worry about set, which is the squiggle lines. I'll show it after we do the interval real quick. Because I think it's always good to know both. Yes, you'll have two unions in this one, right? Because you got two numbers that you're throwing out. So where do we start? Okay. And is that a bracket or parenthesis? Parenthesis. Because infinities always get parentheses. And then where are we going? Negative 6. Good. Yes. And then what? Parenthesis. Union. Parenthesis. Yeah, remember that's our jump. And where do we pick up at? At negative 6. Because you're jumping over negative 6. And then where are you going? To 9. Then what? Parenthesis. Union. Parenthesis, because we're jumping over 9. Yeah, you got it. You're rolling. Then the 9 and off to infinity. There you go. There is your interval notation. Again, you don't have to do set, but I do like to show it because I think it's important. Do your little embellishments, the braces with the X and the line. And then all you do is you put these two answers, that X equal to 9, X equal to 6 in here. And what do you put through the equal signs? A slash. Well, and mathematics-wise, and I wrote it up kind of bad, we like the smallest number first, then the largest number. But as long as you got both of them there, for me as a mathematics teacher, I'm like, yes, you're good. But since I am a mathematics teacher, let me fix this. Yeah, usually we like the smallest number first, then the largest guy. But again, you don't have to know the set. It's the interval that you need to focus in on. But I like to always talk about the set. Okay. Question 3. Simplify, simplify, simplify. And in order to simplify, what do you got to do first? Factor. So we got to take these and we need to factor them. Again, we're going to make it pretty straightforward. Your A is 1. So hopefully the factoring will be nice and quick. Because there is a lot of factoring. Yes, you have to factor the top and the bottom to simplify. Four and 6 for the top one. 4 and a negative 6. Because we need two numbers to multiply to a negative 24, but add to a negative 2. So yeah, a positive 4, negative 6, those multiply to the negative 24. And when they add them, you get the negative 2. So there's your top. Absolutely. Negative 7, negative 6 to the bottom. Because 7 and 6, both negative, when multiplied, give you the positive 42. And when you add those together, yeah, you get the negative 13. Perfect. So now that everything is factored, now you can do the simplifying. How do we simplify? Yes, this is the crossing out. Yeah, cross out the x minus 6 because it's the same from the top and bottom. When you are simplifying, you're looking for what is in common between the top and the bottom, and they're going away. Now, usually, remember when I was in class, I said it's like they cancel each other out, but really what's happening behind the scenes is it makes the number 1. X minus 6 divided by x minus 6 is 1. But since it makes the number 1, it doesn't change anything. That's why I just says it's kind of like canceling itself out. So, what is the final answer? Because nothing else cancels. X plus 4 over what? X minus 7. There you go. Now, some people will also try and say, hey, Mr. Armstrong, can we, whoa, my 7, X minus 7, come back. Can't we cancel out these two? And I'm like, no. Why can we not cancel them out? Yeah, it's a part of this plus 4. It's a part of this minus 7. And in class, we talked about how we can only cancel this out if we're taking everybody out. If I had an x plus 4 on the bottom, that matches it. So the only way we're going to take it out, because they're all together. So there's that answer. Good. Good job. Cool. Do it again. Be careful of this one. Yes, you still got a factor. Question is, what kind of factoring are you going to be doing?
Oh, no, that's, what's it called? A minus B.
Say it again. Not an LCD on this one. We're not adding or subtracting or clearing the fraction. What kind of factoring are you doing? Yes, the greatest common factor. This is all about a GCF. Both the top and the bottom have GCFs. You need to pull them out. Find that GCF. Yeah, because nothing's squared, so that's why we don't worry about difference of squares or anything like that. It's just plain old X's up there and things like that. So, going to pull out a 4 because both of these can be divided by 4, right? All right, so if I pull out a 4, what do I have left? Careful. 9 minus x. Careful. Because we didn't pull out a negative 4 to make it x minus 9. We just pulled out a 4. What do you think is coming out on the bottom? Say it again. No, what's the GCF, silly?
Oh, 6.
6. There we go. Pull out a 6. What do we get on the bottom? There you get x minus 9. Oh. Anything canceling? No. But do two of these parentheses almost look like each other?
Yeah.
Right? What's the matter with them? They're backwards, right? The signs are off.
Yeah.
I got a positive 9, I got a negative 9. I got a negative x, I got a positive x. What should we probably have pulled out in the top to really fix that? A negative. So I like where you were going with that, Natalie. But this guy right up here should have been a negative. Because we want to flip these signs that are right in here so that the top parenthesis matches the bottom. And when you pull out a negative, that just changes your signs. So the 9 will now become negative. The x will now become a positive. When your parentheses almost match, but the problem is their signs, pull out a negative. So now they match, right? Yay! Now we can do some canceling. What's going away? What simplifies? Yes. Anything else? Yes, we can reduce these. So if we write down what we have, because maybe some people didn't see this right away, maybe you write this down. You got to make sure that whenever you have a fraction, remember in mathematics, we always like to reduce. So maybe you crossed stuff out and you wrote this down and then now you realized, oh, stuff can still reduce. Go ahead and keep reducing. -4/6 reduces to what? -2/3. Perfect. There you go. That's the final answer we want. So in this one, little piece that you had to remember is pull out a negative to get our parentheses to match because they were really, really close. Just the signs were off.
I think we had one before, right, where you just pulled out the
Yeah. Yeah.
So that's like a -1, right?
Mm-hmm. Yep. Yeah. Cool?
Yes.
All right, moving on.
Really easy.
All right, so right here, we're going to evaluate. I feel like I have some missing in there. Nope, that's about right. We're going to evaluate. So all they want you to do is what with these numbers that are right here? Who is that?
That's your X.
That's your X. All they want you to do is take those values, each one individually, plug it in. Kick me out an answer. Who is this? That's your Y value. So you'll need to plug that into the Y to get the last one. So we'll talk about the last one soon enough. But go ahead, do the first three. We're telling you what X is. All you got to do is plug them in. Kick me out some answers. Good. So that first one, I like what you said, Lorraine. 0/0 plus 4. And then you're going to give me an answer.
4.
No.
No? Oh. 0, yeah.
Yeah. On the bottom, yes, we get 4, Lorraine. I agree with you. But on top, you have 0 divided by 4, which when you divide that is 0. So that's your first answer there. What's the next one going to look like?
-2/2 plus 4.
There you go. What's going to happen there? Say it again. 1/4? No. -2/2. Don't forget to put these together. -2 plus 4 is 2. Don't do any canceling. Go ahead and work on your PEMDAS and then reduce. Okay? So what is -2/2? -1. Cool beans?
Yes.
All right. What do we do for f of 5?
5/4.
Okay. 5/9. Because 5 plus 4 is 9. Does that reduce?
No.
Nope. Then there's your answer. Any questions on the first 3? Yeah, we're on that one, number 5 right there. Okay. So then, let's jump down to this guy. You told me this guy was y, right? The -1 right there. So remember, f of x is a fancy way of saying y equals. So up in our equation, we really have this. That f of x part was really y in disguise. So when we take this -1, we plug it in for the y, right? Yes. Good, I'm glad you agree. So how do we solve that? We plugged in the -1 for y. I got to figure out what x is.
okay, 1 over 1 or?
Yeah, I like that idea. So let's slap this guy over 1. Now, how would you solve that? Yes. Most of the time, you got to see that denominator of 1 over here, and then you're like, oh my gosh, cross multiply. Yeah, cross multiply. That's how it's going to work. So what's negative 1 times x plus 4? Negative x and a negative 4. That's right. Because again, you're taking that negative 1 to both of those. Okay? So negative x and negative 4. And then what's 1 times x? Yeah, x. Or if you want to call it 1x, it's all the same. Okay? And now you're ready to solve. What are we going to do? Yeah, put the x's together. How do I get them together, though? Move 1 to the other side. Who you want to move?
Does it matter?
It doesn't really matter. Just be careful if you move this one right here to the left side. You still will have an equal sign. I know a lot of people that will pick this one up, move it over here, and then it's like the equal sign disappears magically. Don't let that happen. So who do you want to move? Yeah, I'd grab this negative 1x and move it over to the right side. But if you did pick this one up and move it over here, you would have this, just so you know. Because I moved this one right here, that leaves me with 0 there. Okay? But let's go ahead and move the negative 1x. So how do I move a negative 1x? Plus 1x. So I got negative 4 equals, what's 1x plus 1x? Yes. And now what do you do? Divide. Divide by what? Dose. X equals, what's negative 4 divided by 2? Yay. There it is. Yeah, a little cross multiplying. Cool beans? Right on. So yeah, there's about 4 answers on this thing. 3 where you're plugging in the x, and then 1 where you're plugging into a y. All right, question 6. Dividing rationals. Remember, division doesn't really exist for us. What happens with division?
Flip it and, well, KFC.
Turns into multiplications. Yes, KFC, not quite with the KFC, that's chicken. We want KCF. We want KCF, Kentucky Chicken Fried. Yes, that's right. K for keep, C for change to the multiplication, F for flip it. So we're going to keep this first. We're going to change division to multiplication, and then we're going to flip the second fraction. And what do you have to do now? Factor. So you got a lot of factoring right here. All 4 positions factor. Both numerators, both denominators. Give you a moment to process. If you want any chips or granola, right over there, have some. Be careful on that first numerator, just so you know. Even though it looks like a cubic, it's not. Just curious. I know you're still working. What did you guys do for that first numerator? Pulled out an x. Yes, you need to pull out a GCF first, and then continue to factor. So I like what you said. Pull out that x. And if I pull out that x, what's left? There you go. Continue to factor. Because that x squared minus 64 continues to break down. Good. Check out a calculator if you want. Okay. And you guys can talk to each other too. I highly encourage it. All right. Let's kind of push forward a little bit more on this guy. What does the x squared minus 64 factor out to? Yeah, there you go. The x plus 8, the x minus 8. Was this x squared minus 64 anywhere else? Yeah, right over here. So you already know what these guys do. All right. So let's talk about the first denominator over here, the x squared minus 5x. How does that factor? Yeah, pull out an x, just like what you kind of did up above. Pull out an x, and what's left? Yepers. There you go, so that guy's good. And then the only question is, what does the x squared minus 14x plus 45 factor to? You got it. Because again, a negative times a negative is a positive, and 9 times 5 is 45. And negative 9 and negative 5 add to a negative 14. All right, so now that everything is factored, we can start getting rid of stuff. What's going away? Both of these, x plus 8s, x minus 8s, cancel out with the x plus 8, x minus 8 down there. What else? X minus 5s are going away. Anybody else? There's one other piece that goes away. The x's right here. This x takes out that x. But you may not have saw that right away because you could do it in the next step too. But they really do take each other out right there. So what's left? X minus 9 over 1, or we can just call it x minus 9. They're both the same. Cool beans? Yeah, a little bit of factoring. Okay, now we're into adding and subtracting, your favorite. In order to add and subtract rationals, what do you got to have? Do we have common denominator? Yay! So that makes this one not as bad as the next one. Because the next one, we're not going to have common denominators. But this one's great. It's already got the common denominator. Everybody's got x plus 4. So what's the denominator going to be when we add together? X plus 4. Yay! And then what do we do with the numerators as we add and subtract? Yeah, combine them. Combine like terms, to be specific. Anybody getting together in that numerator? No. The x squared, the negative 2x, the negative 24, no one gets together, like as in combining, but do they disappear? No, so we just write them all down. No one got combined, but they don't disappear, so we just write down what we have. We have x squared minus 2x minus 24. And then all you do now, reduce, factor, and all that good stuff. Cool. Yeah, we got a plus 4 and a minus 6 because 4 times or positive times a negative is negative, and 4 times 6 is a 24. And then when you add those two together, you definitely get the negative 2. See, like I said, most of your factoring, we're going to keep that a value 1, which makes it factor a little bit faster for us. So now that we're factored, what's going away? The x plus 4s, absolutely. So what are we left with then? X minus 6, perfect. X minus 6, or you can call it x minus 6 over 1. Yeah, on the test it shouldn't matter. Okay. Cool beans on that one? All right. This one right here, I think this is going to be your longest problem on the test for you. Because, again, we don't have the common denominator. So that's where we got to find that LCD now. This is where LCD has become important for us, especially on the rest of the problems on down from 8 all the way through, I believe, 13, if I remember correctly. Got to know LCDs. Yep, factor them first. That's the key. Because you can't find your LCD unless they're factored. All right, so it has this first denominator factor. You got it. X plus 3, x minus 7. Because a positive 3 and negative 7 give you the negative 21. Negative 7 plus 3 give you the negative 4. Perfect. What does the second one factor to? X plus 4 what? Not minus 3. Positive 3. Yeah, because there's no negatives up here, so negative or positive 3 got me saying negative 3 now. Positive 3, positive 4 give you the positive 12. Positive 3, positive 4 when added together give you the positive 7. Cool. So here are the denominators. what's going to be the common denominator between both of them? X plus 3. I like it. You're not done though.
You have to keep doing correct.
So what else do we need? You got it. An x minus 7 and an x plus 4. Remember, as I talked about it in class, the LCD contains every denominator. And if I cover up the x plus 4, see, there's my first denominator. If I cover up the x minus 7, there's my second denominator. Your LCD contains both denominators. So now you know the common denominator. Now we can start writing our fractions, because both denominators are going to have x plus 3, x minus 7, x plus 4. X plus 3, x minus 7, x plus 4. We just need to adjust whatever's missing. So here's my current denominator. Here's what I want. What's missing? It's missing the x plus 4. So that means we multiply top and bottom by x plus 4, because that's what's missing. I've got the x plus 3, the x minus 7 up here, but I'm missing the x plus 4. So multiply top and bottom on this guy by x plus 4. So what does my numerator become there? No. No canceling. You're timesing it. No canceling until after we get done adding and subtracting.
So you go x times negative 5x, right?
Which is negative 5x squared. Because we took this guy and multiplied the x. And then what?
4 times negative 5x.
And what does that give us?
Negative 20.
Perfect. Any questions about our new numerator? Okay. So, again, here's what I currently have. Here's what I want. What's missing? The x minus 7. I've got the x plus 4, x plus 3, x plus 3, x plus 4. I'm missing this guy. So I need to multiply top and bottom by what? X minus 7. Good. X minus 7, x minus 7. So what's my numerator over here now? Don't worry about the sign yet. Just x minus 7, right? Because 1 times x is just x. And 1 times negative 7 is just negative 7, right? Everyone good on the numerator so far? All right. So let's come down here and focus in on this guy. When I talked about adding and subtracting in class, I said subtraction you need to be careful of. And again, just like division doesn't really exist, subtraction doesn't really exist. Subtraction is plus and opposite. So I'm going to go ahead and turn this into a positive. And what's that do to our second? Yeah, changes your numerator. So usually when I have subtraction, I'll turn it into a positive, and then I'll come over here and change all my signs. Positive x became a negative x. A negative 7 becomes a positive 7. So when I have subtraction, I turn it into a plus and flip all the signs in the numerator of the second fraction. Does that make sense? Okay. So now all we do is what you guys told us a couple minutes ago. How do I add and subtract fractions? What do we got to do? No factoring yet. Combine like terms. Remember, take care of your numerators. Yeah, combine like terms. Your denominator will still be the same. Don't do anything to the denominator. But the numerator, what do we get in the numerator? No factoring.
You have a negative 5x squared.
Yes.
And then x. Right? Oh, I'm sorry.
Nope. Negative 21x. Because these two right here are going to get together. A negative 20x and a negative 1x give you a negative 21x. And then what? And then a plus 7. Okay, remember you combine like terms across the top. No one got together with the x squared, but the two x's get together, become the negative 21x, and then that 7 just comes along for the ride. Now is the time where you want to try and factor and cancel. When it comes to adding and subtracting, you factor and cancel at the very end after you have done all the adding and subtracting. Like I said, this is your longest problem because you got a lot to deal with. Yeah, this one, notice our A is not 1, so it's a little different. So you either do, yeah, however you were taught factoring, like my students learned the AC method. You can guess and check. They didn't learn that one, but you can try guess and check. You can do the box method. If you watched my video on box method, you could do slide and divide. So, yeah. So whatever your method of factoring a trinomial is, because that's what you have in the numerator, you just do it. So what do you think? Yeah, it doesn't factor at all. There's no way. Because if you take 5 times 7, you get 35. The factors of 35 are 1 and 35 and 5 and 7. And none of them will give you a negative 21. So, no, it's not a D&E. That's the answer. That's the answer. Now, there is one thing you could do if you really wanted to. Normally, we do not like x squareds to be negative. So you could pull out a negative 1 if you wanted to. And another possible answer, again, that answer that you see right here is just fine. But if you wanted to pull out a negative 1 and make this 5x squared plus 21x minus 7, that is also a valid answer, because in mathematics, when we do true factoring, we want our x squared to be positive. Even with the x squared positive, it still doesn't factor, just so you know.
Yeah.
So either one of those are correct. This is what we called a factored answer. This is what we called a multiplied out answer. So both are A-OK. Okay? Yes. Good. Glad you agree. Let's move on. Like I said, I think that one's your your longest problem because it just takes a while to get through it. All right, so we want to simplify the complex fraction. Now, I know my students were taught to clear the fraction. How about you guys? Were you taught how to just clear the fraction out? Or do they teach you to add and subtract and then do the keep, change, flip? Okay, well, I'll show clear the fraction because that's what we do in our book anyway. All right, so up here, what are all your denominators? We have 4 rationals up here. We have a rational, a rational, a rational, a rational. There's 4 of them. What are all the denominators on those?
1, n, and 2.
Yeah, don't worry about the 1, but n and n squared. Remember, in order to clear the fraction, we need the LCD. So what is the LCD between n and n squared? N squared. Yeah. So we're going to clear the fraction. We're going to get rid of every fraction that's up here and make this easier to deal with. So everybody's going to get multiplied by n squared. We're going to play Oprah. You get an n squared, and you get an n squared, and you get an n squared, and you get an n squared. Everyone's getting multiplied by n squared. And now, start doing some canceling. So this 1 has no denominator. So we don't have to worry about canceling anything out. So we just multiply. What's n squared times 1? N squared. Then you got your minus sign. What's going to happen between this n squared and that n squared? Cancels, because we're clearing the fraction. So what am I left with there? 25. So there's your new numerator. Much easier to deal with because it's no longer fractions. So we just repeat the same thing. What's going to happen down here between the n and the n squared? Yeah, it's just going to become n, right? This guy goes away. This n squared becomes just n because only one of those n's gets canceled out because there were 2 there. So what do I get when I take n times 1? Yay! And then I got a plus sign. And then what's going to happen between these 2 n squareds? Gone. And what am I left with? Is that how you guys were taught? Okay, good. So there we go. All we do now is simplify this thing. Like what you guys did in chapter 5.1. No, 4.1. Okay? All we got to do is simplify, which means make sure everybody's factored and then cross off what goes away. Just so you know, the bottom will not factor. It's only the numerator. So what does that numerator factor to? N plus 5, and what was the other one? N minus 5. Good. So what is canceling out? Yep. So what are we left with? You got it. N minus 5, or you can call it? Yep. Either one. All the samesies. Okay. We're getting near the end of the rationals. All right. So here we're solving now. Solving. It's kind of like it's kind of like what we just did with the complex fractions. You got to clear the fraction. You have 3 denominators. What are they?
2x,
So we need that LCD. So between those denominators, 2x, x, and 3, what will be the LCD, the common denominator? 6x. Yeah. Because 6 can be divided by both 3 and 2. And I need an x because these guys up here have x. So again, we're going to play Oprah. Everybody's getting multiplied by 6x. You get a 6x, and you get a 6x, and you get a 6x. And now we start canceling and figuring out what we have left. What's going to happen between the 6x and the 2x? And they become what? Nope. What's going to happen between your x's? Those x's will cancel. But yes, 6 divided by 2 gives us 3. So I've got 3 times 5. 15. Plus, what's going to happen between the 6x and the x? Yeah, the x's go away. So that leaves us with 6 times 3. $18. Perfect. Equals. What's going to happen between the 3 and the 6x? Divide to 2, because the 3 goes away and the 6 becomes a 2. So what is 4 times 2x? 8x. Now this is a whole heck of a lot easier to deal with than what we had a moment ago. So what are we going to do? Yeah, put these two like terms together. What is 15 plus 18? 33. Okay, I trust you. Equals 8x. Now what? Yes. Divide by 8c's. Divide by 8. And x equals what? 33 over 8, because they want the fraction. But again, we're not done. Remember, in this section, these are the possible answers. What do you have to do? We got to check it. And how do we really just check it real quick? Into the x, but which x do we really care about? The ones where? We want the x's in the denominator. Because remember, we don't want the denominator to be what number? 0. That's why we check it. We need to make sure that our answer of 33 over 8 doesn't give us a 0 in the denominator. Okay? Because if it gives us a 0 in the denominator, throw it out. So if I take 2 times 33 over 8, will that be 0? No, it won't be 0. It'll be some other number, just not 0. As long as it's not 0, we're okay. If I put 33 over 8 in for x up here, will that be 0? Nope. So is this answer okay? Absolutely. Valid answer. Whoops, didn't mean to erase. Yeah, so make sure at the end you check your answers on these. Because we got to make sure that it is not 0. Okay? Check those answers. That's right. All right.
If it turns out it doesn't work, then our answer is D.
Well, it depends on if you have any other answers left.
Oh,
Okay?
Oh, in case you have 2 answers.
Yeah, if you have 2 answers and you throw out 1, you still have an answer. But if you only have 1 answer and you throw it out, then yes, that will be a D and E. All right, so let's take a look at this guy. So again, we only have 2 fractions really. What are their denominators? X and x squared. So we need the LCD. What is it going to be? X squared, just like the n and the n squared. And again, play Oprah. You get an x squared, and you get an x squared, and you get an x squared. All right. So now you just start doing the canceling. So there's no canceling for this first piece, the x squared and the 5. So what is 5 times x squared? 5x squared. Perfect. Yay. Okay. What's going to happen between the x squared and the x? Yeah, one of the x's goes away. Denominator goes away for sure, And then that x squared just becomes x. So what is x times 29? 29x. You're so thrilled. Equals. What's going to happen over here? Yes. Negative 20. Perfect. Now this is much easier to deal with. What now? You got a what? There's no like terms to get together because the x squared and the x are not the same, so you can't put those together. But what else do we got to do? We got to move the negative 20. Why do I have to move the negative 20? Why do I want to equal it to 0? So you can factor. You can only factor when you are equal to 0. That's why we move the negative 20. How do I move a negative 20? Add it, yeah. So we're picking this guy up, moving it to the other side. And we have 5x squared minus 29x plus 20 equal to 0. And now you can go through and you can do your factoring. If you are not equal to 0, don't factor. Oh, sorry, plus 29x. My bad. So 5x squared plus 29x plus 20 equal to 0. Yeah, the A's not 1 on this one, I know. But that's all right, we can get through it. I said the A's not 1 on this one, so again, you'll have to go through your AC, your box method, your slide and divide, your guess and check, whatever it is that you like to do for trinomials and get to the answer. There's no GCF in this one. Because the only thing that gives you 29 is 1 and 29. Oh, factors? If you want to find factors, I don't have the calculator up. Let me bring it up real quick. You're going to go into the graphing. So you'll push y equals. And then you will put in your number divided by x. And then you'll go to the table. I'll show you that real quick. So what do we got? 5 and 20, right? So slide this over real quick.
Well, I was wondering because earlier we had a problem and I can't remember how to do that.
So like I said, we're going to go to y equals. Your 5 times 20 was 100, right? Yes. Good. I'm glad you agree. So you put 100 divided by x. Hit second graph. And now you can see your factors. Anybody that's a decimal, ignore. So 1 and 100 is a factor. 2 and 50 is a factor. 4 and 25, 5 and 20, 10 and 10. So there are all your factors. How do you get a positive 29? Yes, you do. 4 and 25. Because 25 plus 4 is 29, right? There you go. That's how you get factors. All right, how does it factor? So just checking everything out. Yep, that looks good. So what do we do now? It's factored. What now? Equal than to 0. There we go. Yes. 5x plus 4 equals 0. And x plus 5 equals 0. So how do we solve this first guy right here? Move the 4. 5x is equal to negative 4. Divide by what? 5. So what does x equal? Negative 4/5, because that does not reduce. That's one possible answer. How do we solve the other guy? Minus 5. So x is equal to negative 5. So again, what do we got to do? Check. So we're going to check negative 4/5 first, and then we'll check negative 5. And again, what number do we not want? 0. So we come up here. If I plug negative 4/5 in here for x, is that 0? Nope. If I take negative 4/5 and square it, is that 0? Nope. So negative 4/5, valid. Let's check negative 5. If I plug in negative 5 here, is that 0? No. If I plug in negative 5 there and square it, is that 0? No. So negative 5 is also valid. Whoops. Yes. You put in your two answers and separate them by a comma. I don't think it matters. Let's go up and look real quick. No, doesn't matter. Just list the values, separate them with a comma. Okay? Here we go. Question number 12. This is the one I've seen on past exams that gives student the most trouble. It's not long by any means, but it's the one that gives them the most trouble. So beware of this problem. And all that really kind of happens in this problem is we change the numbers on top, and we might change the letters down at the bottom to A, B, C, D, or A, B, C, or X, Y, Z. We just kind of change the variables at the bottom or change the numbers on top. So again, in this one, you're focusing in on the letter F. We want to get F by itself. Okay? What are you going to do first? LCD. We got to get them all out of the fraction. Okay? So we need to multiply everybody by the LCD. Well, what are my denominators again? All right. So what is the LCD for P, Q, and F? P, Q, F. Everybody's got to get multiplied by the P, the Q, and the F. So, PQF. 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 All right, so let's figure out what we got left, okay? So what's going to happen between PQF and the P? P's go away. So what am I left with there? So what's QF times 2? Everyone good so far? Okay. What's going to happen to the PQF and the Q? And I'm left with the PF. And what's PF times 9? Everyone picking up what I'm putting down? Good. Now I got PQF and then I got an F. What's going to happen to those? F's go away. 4PQ. All right. So there's your first step. Now again, who are we after? F. But I have 2 of those. It only works if I can have 1. So what do we need to do now? And that's true. We want to. But how do I do that? I can't. I got two F's. Can't combine them. No dividing yet. We will. That's the last step. But what do you have to do first? How do I do that? And this is the step that gets the students. Don't take out the Q and the P. Take out what? F. It's a GCF. Both of these have an F, right? Pull it out. Pull out the F. Because how many F's will that create? Just one. And one F we can get by itself. So what's left inside if I pull that F out? 2Q plus 9P. Does that make sense? It's a GCF step. Pull that F out. And then what are you going to do now? And you said it a moment ago. Divide. Because what's going on between the F and the parenthesis? Multiplication. How do you get rid of multiplication? Divide. So, because there's multiplication going on there. So we're going to divide both sides by what? 2Q plus 9P. 2Q plus 9P. And that right there is what F equals. So what does F equal now? 4PQ, good. Yes. There's F. Because there's no simplifying or reducing. Okay? Let's go through those steps again just to make sure that you guys got them. There was only 3 things we did. Step number 1, clear the fraction. We cleared the fraction. That's when we multiplied everybody by the LCD. Step number 2, you saw that we had 2 F's, so we pulled it out as a GCF. And then that's step number 3, we did division. And we were done. Cool? All right, keep that in mind. All right, question 13, and then we'll move on to radicals. We'll be out of chapter 4. So this is the last chapter 4 question. And then everything else from 13 on down, or 14 on down, all about radicals. Chapter 5. That part will get very, very fast for you once you get to the radicals. That's the rational part that takes the most of this test. All right, so it says one driver drives 25 miles per hour faster than another driver. They start at the same time, and after a certain amount of time, one driver has driven 150 miles and the other driver has driven 275 miles. What are the speeds of the 2 drivers? Very common question. So, in this problem, there's one fact that you have to remember. It's like an equation, okay? Do you guys remember the equation for distance? But it's not the big giant square root of x1 minus x2, not that guy. But what is the equation for distance? It's very, very short. S times time. There you go. Or sometimes we call it RT, rate times time. So this is what's going on in this problem. And we have 2 drivers, and we're going to fill in what we know. Okay? So we've got our slow driver. And we got our fast driver. So let's fill in our equation for each one of these. So the first thing, let's start out with D. How far did the slow driver go? 150. If you're a slow driver, you're not going to get very far. Okay? Does that make sense? So even though it doesn't say slow driver went this, fast driver, this is where you got to use a little bit of logic in this one to start thinking about what's going on. So the slow driver has gone 150. How far did the fast one go? 275. Good. Okay. Now let's talk about the rates. It says one driver drives 25 miles per hour faster than another driver. So what is that going to look like? Nope. Someone will have a plus 25. Who will have the plus 25? The fast driver. Can't be the slow one, because if I add 25 miles per hour, that means that's the fast one, right? So this driver over here has to have a plus 25, right? So what's going to be in front of that plus 25 then? R, or call it X. We just don't know what the rate is, right? And that R represents our slow driver's speed. Because when I add 25 onto that, that gives me the fast driver's speed. Picking up and down. And then last but not least, do we know how long they drove? They started at the same time and then they stopped after a certain amount of time. So what's that tell you about the times? No. They're the same. Times are the same. They drove for the same amount of time. They started at the same time, and then after a certain amount of time, they stopped at their mileage. Okay? So the one thing that is the same between these two is time. Notice I put that in a different color because that's important. If their times are the same, then that means we can set them equal to each other if we knew the equation for time, right? How can I get t by itself? Yeah. Divide by what here? Divide by r. So t for this guy is 150 over r. How can I get t by itself for the fast driver? Divide. Yeah, don't change your process. Divide. What are we going to divide by? R plus 25. Now you know the time for the fast driver. 275 divided by R plus 25. And since both of these drove the same amount of time, I can take these two pieces, set them equal. Because their times are the same. You follow me on that? Which gives us a rational to solve. 150R must equal the same as 275 R plus 25. Because they drove the same amount of time. Okay? How can we solve this? You don't need like denominators. What were you saying? Yeah, we can cross multiply on this. Or if you really wanted to clear the fraction, you could do that, but that's just silly work on this. It's just easier to cross multiply. So what is 150 times R plus 25? Whoop. Sorry. Screen switched on me. Go away. No. There we go. Sorry, say that again. No, 150R plus what? 150 times 25, because when you multiply those, you're taking 150 times that whole thing. So I need to know what is 150 times the 25. Everyone good so far? Okay. And then we'll take R times the 275. So what is R times 275? 275R. Now what are you going to do? Nothing really to combine. Yeah, let's move this 150R to the other side. Get all of your R's on one side. Get all your variables on one side. How do I move 150R? Okay. So we'll have 3,750 equal to what? Okay. Now what? Divide by 125. Okay. So R is equal to? You got it. Miles per hour. Who is that? Is this the fast driver or the slow driver? This is your slow driver. Because if you go back and look at our pieces here, R was under our slow driver. Make sense? Okay. So we know what the slow driver is. How do we get the fast driver? Add 25. And what do you get? 55. Slow driver. Take 30 plus 25 and you get the 55 miles per hour, which is the fast driver. Cool? If you get a decimal on this problem, my advice to you, go back and rework it. These should be relatively nice numbers, okay? So just kind of food for thought on that one. Careful. All right. That ends chapter 4 right there. Everything else, chapter 3. So right here it says simplify the radical. So simplifying the radical, guys, super easy. Use that calculator. A lot of these problems right in here, use that calculator for, okay? So let me bring up my calculator, and we're going to simplify the cube root of negative 343, right?
Yes.
Yeah. So where do I go to put this in? How do I get that cube root in? Nope, not alpha.
Second.
Nope.
Find the cube root. Math.
Math. Math. Which one? Yeah, number 5. You could use that one, or you could do 4, but I like to go number 5. So let's grab 5. And then what do I put up here? A 3, good. And then I go inside my radical, and I put negative 343, right? Negative sign is right down here by enter. And enter. There it is. There's your answer. Negative 7. Done. That's it. That's all you need. Let that calculator do the dirty work. Okay? So, equals negative 7. Done. Moving on. Any question on number 14? Like I said, this is where everything should start to speed up. So, the next one says, convert to scientific notation. Do not round the answer. So, how do I convert to scientific notation? What am I going to do with this number? I need to get the decimal point where? Between the 5 and the 4. Because remember, scientific notation must be between the number 1 and 10. So my decimal is right here. I keep moving it until I get between the number 1 and 10, which is why I need to go between the 5 and the 4. Because that will give me 5.49. And that number is between 1 and 10, right? Yeah, Good. Now, this will be times 10. We need to figure out the exponent to the 5th power, because that's how many times I moved my decimal. 1, 2, 3, 4, 5. And whenever you move to the left, it is a positive exponent. If I was moving my decimal to the right, it would have been a negative exponent. Okay? That's it. That's all we need. There's your answer. Moving on. So again, it says use radical notation to evaluate the expression, simplify if possible. Go to your calculator. Let the calculator do the dirty work. Okay? So we go to our calculator. We're just going to put this in and see what it says. Okay? Ain't no one going to know if you made radicals or not. So, negative 16. And we're raising it to what power? Not shoot power.
Wait.
Not weight power. Caret key's right here, Lorraine. That gives you your exponent.
Yeah, I forgot to put it in parentheses.
All right, what's our exponent though?
Oh, exponent is 3.
No. What's it say on the paper, sillies?
Oh.
Negative 1/4, right? How do I put in a fraction in my calculator? Say it again. You can hit the divide button, there, but there's another way. Where's your best friend?
You just start over. Lost.
Lorraine, are you all right? Did you put parentheses?
Okay, now I have to start over. So it's
All right, parenthesis, negative, 1/6, parenthesis, hit your caret key, the rooftop. Yep, now you're right back where I'm at. How do I put in a fraction? Come on, sillies. Say it again. No, alpha y equals. Alpha y equals. There's your fraction buttons. Hit enter for the first guy, and now we can put in our negative 1/4. Negative 1/4. Good? And we hit enter. Boom! What's that mean? D&E. Because you got an error right here. It says non-real answer. So that means that is a D&E. It does not exist. For right now. A negative 16 to the power.
To the power.
Yeah. Just like what you got written right here.
Right. Just trying to remember how I used to calculate.
Yeah. Okay? Let the calculator do the dirty work. Like I said, this is where things really speed up for you. Supposed to.
All right.
Everyone good on that one? All right, moving on. So, from here, it says rationalize the denominator. So we talked about this. This is one ugly denominator, I just got to say, but that's all right. We can rationalize it. How are we going to rationalize this thing? Because rationalizing means we don't want the radicals in the denominator, because some Joe Schmo long ago said, hey, we do not like radicals in the denominator. You guys haven't been taught this yet. You're going to get that on Monday. So how do we rationalize? Silence in the audience. In order to rationalize this, usually what rationalizing consists of is you, slipped on my mind, multiply by whatever radicals in the denominator. That's usually what rationalizing. But this one's a little different because of the addition that's going on down here. So we use what is called conjugates. You might remember conjugates from when you looked at the complex numbers, because we had something called a complex conjugate. So all a conjugate is if I have something, two ideas being added, the conjugate to it would be the two ideas being subtracted. You just reverse the sign. if I have two ideas being subtracted, the conjugate would be the two ideas being added. That's what a conjugate is. Addition becomes subtraction, subtraction becomes addition. So, what am I going to multiply top and bottom here by? The denominator. What will be the conjugate of my denominator? Nope. Still negative 7. Nope. Minus, because we're changing the addition to subtraction. And then radical 175. And if I do that to the denominator, I also have to do it to the numerator. Now, a couple other things to remember. That when you take two radicals that are the same and multiply them, then whatever's underneath the radical will pop out. Like the square root of 10 times the square root of 10 is 10. The square root of 23 times the square root of 23 is 23. Okay? All right. The other thing that's really good to remember is that if I'm taking conjugates times each other, you don't have to worry about the middle term. So in other words, usually you FOIL this. Don't worry about the O and the I. Because what will happen to your middle terms is they will cancel out. So whenever I deal with conjugates, I always say, do the Florida. Because all you got to do is the F and the L. It's not FOIL, it's just Florida. Because the O and the I part of the FOIL, again, when you multiply conjugates, cancels out. So I'm giving you some ways to kind of speed things up and work smarter, not harder. So up here, these two are your conjugates. So that means all I got to do is multiply Florida style. Multiply the first, multiply the last. As long as they're conjugates, you can do Florida. In the numerator, are these two conjugates? No. So there you'll just do distributing, because that's what they want you to do. Take the negative 2 and distribute through. Okay? All right, so let's start doing some multiplying. Let's take care of the numerator quick. We just talked about this. All we got to do is distribute. So what's negative 2 times negative 7? Positive 14. Good. And what's a negative 2 times a negative square root of 175? Nope. Remember, this number can't multiply that radical. Numbers multiply numbers. Radicals will multiply radicals. What's a negative times a negative? Positive. 2. Yes. That 2 cannot go into the house. It's outside the house. It's outside the radical. All right, so down here, we just talked about this. All I want you to do is Florida this bad boy. So that's your first. Nope, it's not positive 14.
Oh, 49.
Positive 49. Yeah, there we go. And then we'll finish up Florida with the L. What's a positive square root of 175 times a negative square root of 175? The radical cancels, and what are you left with? What? Yep. Because a positive times a negative is a negative. And remember, these two radicals are the same, right? So the number pops out. Okay? So now all that's left is a little bit of cleanup. Okay? So first things, let's put together our denominator. What is 49 minus 175? Negative 126. Okay. All right, so now Now we start the simplify process. So we've done a little bit of cleanup. We combined like terms. So now we need to simplify. The first thing you're going to want to simplify is the square root of 175. Focus in on that. Don't worry about anything else. Let's reduce this square root of 175. Square root 175. Remember in my class I taught you either what I call the good child, bad child, which is finding those perfect squares that work, and the non-perfect square, which is what our book does. I also showed you how to do a tree diagram. It's your choice. Those of you that haven't had me, I'm sure you probably learned how to do what I call the good child, bad child, which is find the perfect squares. So what is that biggest perfect square that will divide that number? And you break it apart into two radicals. Say it louder. 25 and 7. I like it. 25 and 7. And what's the square root of 25? 5. Square root of 7 stays, right? So this piece that we have right here, we're going to put it in right there. Okay? So we still got the negative 126. We still got the 14. But now you have 2 and a 5 square roots of 7. What's going to happen between the 2 and the 5? Say it again. Multiply, and what do we get? 10 square roots of 7. So that's our new piece there in the numerator. Because 2 times 5 is 10. And the square root of 7 just comes along. So we've reduced the radical, right? Now, focus in on these numbers that are out here. Is there any number that can divide all 3 of those? 2. So let's divide all those numbers by 2, and then we'll be done. That will be the final answer. So, what's 14 divided by 2? Plus, what's 10 divided by 2? What is negative 126 divided by 2? Final answer. Now, the denominator is negative. There are some things you can do with that negative. You can shift it around if you want, because remember, the negative can be in the denominator out front or in the numerator. So this is one possible answer you can put in. It's perfectly A-OK. Another possible answer, just put the negative in front and have 7 plus 5 square roots of 7 all over 63. Or if you want, you can take the negative and take it through the numerator, your call. And have negative 7 minus 5 square roots of 3, or excuse me, not 3, 7. 5 square roots of 7 over 63. So we just took the negative and went through the numerator. All 3 of these are valid answers. There's nothing wrong. You pick your poison. All I did was either take the negative and left it in the denominator, or I moved it out front, or I put it through the numerator. Because the negative can go in either one of those places. They're all valid. Oh, yeah, a little bit of rationalizing on that one, but not too bad. Yes. Okay? All right. Almost done. Solving. Solving. So we want to solve. So that means we want to actually figure out what x is. In order to solve, what do you got to have happen first? Again, you'll see this on Monday. You'll see this on Monday. What do you think has to happen? Because we can't do anything with the radical just yet. Yeah. What do we got to do? What do we got to do with this negative 10? We got to move to the other side. How do you get rid of a negative 10? Yeah. In order to solve radicals, your first step should be to get the radical by itself. And what is negative 4 plus 10? 6. Yeah. Before you can do anything with the radical, you have to get it by itself. Once the radical is by itself, all you're going to do is raise both sides to a power. And what power that is whatever's on the radical. So my radical is a cube root. So what am I going to raise both sides to? A power of 3. Yeah, once that radical is by itself, then you raise it to the power. So this becomes squared, squared. Sorry, not squared, cubed, because it's a cube. You told me that it was supposed to be a 3. I'm just silly. What is the power of 3 and the cube root going to do to each other? Cancel. So we are left with negative 6x plus 246 equal to 216, because 6 to the power of 3 is 216. And now you just finish out the rest of the solving. Once that radical is by itself, and you've raised it to the power, it's just all that's left is the solving. What do we do now? Yeah, minus 246, minus 246. So I've got negative 6x equal to negative 30. And then what? Divide by negative 6. So x is equal to a positive 5. But again, you're not done. You got to check it. Just like what we did with the rationals, you got to do the same thing with the radicals. We need to check this. Is this a possible solution? Now this checking, you have to do the full check. You got to plug it in. You got to make sure that this side equals the other side. The left side and the right side are both the same value. So if I come up here and I put 5 in, what's negative 6 times 5? Negative 30. What's negative 30 plus 246? It's 216. Yes. What's the cube root of 216? 6. 6 minus 10, is that negative 4? Yes. So this answer is valid. If that answer did not come out to be correct on both sides, throw it out. Okay? It is possible to have more than one answer. That's A-okay. Any questions on this one so far? All good? Again, though, before you can do anything, you have to get the radical by itself. And then you raise it to the power. All right, word problem, word problem. And all this is Pythagorean theorem. You all remember Pythagorean theorem. What is that formula? What's the Pythagorean theorem? A squared. Yep. Plus the b squared equal to c squared. And the a and b are considered to be what? What are they called? They're the legs, which are the two sides that make the right angles. And this is the hypotenuse. So, when I always talk to you guys about this, I said make yourself a picture. So it says a building has a ramp from its to its front doors. Okay. So let's just draw a picture real quick. I got a building. I got a ramp. Front doors. Cool? Hopefully you see the right triangle now. If you don't, I worry for you sometimes. Yeah, it looks like kind of like a bird. Yeah, absolutely. So, there's my right triangle, but yes, it does look like a bird. All right, so now let's just fill in what we know. It says, if the distance from the building to the end of the ramp is 14 feet. So, is that 14 in place 1, 2, or 3? It's in place 2, because from the end of the ramp to the building is 14 feet. Cool beans so far? All right. And then it says And the height from the ground to the front door is 13 feet. Was that place 1 or 3? 1. Good. So this is 13 feet. Obviously, you know what you're doing now. Now it says, how long is the tamp? That should be ramp, but it's all good. And also notice in your answer, they want it as a decimal to the nearest tenth. So 1 decimal place, tenth. So obviously we are looking for this guy. And who is this? Is that a leg or the hypotenuse? Hypotenuse. So that means we know the legs, and these are the legs. Which one is A? It doesn't matter. So you pick who you want A to be, you pick who you want B to be, and we plug in. So I'm going to say A is 13 squared plus my B, which has to be 14 squared, equal to C squared or X squared, whatever you want to call it. So what now? All right, so what's 13 squared? 169 plus, what's 14 squared? 196 equal to C squared. All right, 169 plus 196. 365 equal to C squared. Now what? How do I, because I don't want to know what C squared is. I want to know what C is. So what do? Yeah, because how do you get rid of something squared? You take a square root. Just like how do you get rid of the radical? You raise it to the same power. How do I get rid of a power? I take it to the same kind of radical. So a power of 2 deserves a square root. And C is equal to, this will not come out nice and neat, so that means you'll have to round. All right, how do we do it in the calculator? Let's jump to the calculator real quick. So where is it? Let me clear that out there. Where can I put in a radical? Yep, second and the x squared. There's your radical. And what number are we putting in? 365. Enter. And to the nearest tenth, 1 decimal place, what is it? 19.1. 19.1. And it's in feet. Because I always like to talk about labels. Labels are important. You should always have labels. Yep, nearest tenth. That's what the directions said. 1 more, and we're done. Feet, correct. That's right, here we go. Last one, complex numbers. They want you to divide, which is the same thing as rationalizing, because I is a radical of -1 in disguise. It's the square root of -1. So that means we have a radical in the denominator. And again, some Joe Schmo said, I don't like radicals in the denominator, so let's get rid of them. And that's called rationalizing. This is a rationalizing problem. Notice it's addition in the denominator. So what do you think you're going to use? Subtraction. Yes, conjugates, what we just talked about. It's another conjugate problem. And because we got i's, we call these complex conjugates. Okay? Complex conjugates. So if I had A plus BI, the complex conjugate would be A minus BI. If I had A minus BI, the conjugate would be A plus BI. And again, on these, it's going to be like a lot of FOIL. And if they are conjugates of complex conjugates of each other, you just do Florida again. All those same rules that we talked about apply. Okay? One other piece I want to highlight, I squareds, because we will have I squareds. What does I squared become? No. Not a 1, but close. A negative 1. Anytime you have an I squared, we will turn it into a negative 1. Okay? So those are the things to keep in mind for this. So, again, we don't like I in the denominator. So what am I going to multiply top and bottom by? The complex conjugate, which is what? 6 minus 3i. 6 minus 3i. So in the denominator, these two are complex conjugates of each other, so I only have to do Florida. Multiply the first, multiply the last. In the numerator, since these are not conjugates of each other, we'll have to do full FOIL, okay? So in the denominator, since they're conjugates, complex to be specific, only do the Florida, the first and the last. In the numerator, we will have to do full FOIL because they are not conjugates of each other. So let's talk about the numerator. What is negative 3 times 6? Negative 18. What is negative 3 times negative 3i? And just treat I like the variable it is, like an x. So what's a negative 3 times a negative 3i? Plus 9i. What is I times 6? Plus 6i. And what is I times negative 3i? Negative 3i squared. We'll talk about the I squared here in a moment, okay? Let's do the bottom. Again, they're complex conjugates of each other, so all we got to do is just Florida this bad boy. What's 6 times 6? And what's 3i times negative 3i? All right. So let's talk about I squared again. What do I squareds become? Negative 1s. So this right here is really a negative 3 times a negative 1. This right here down here is really a negative 9 times a negative 1. Follow me on that? So my numerator up here, whoa, too far, looks like negative 18 plus 9i plus 6i. What's negative 3 times negative 1? Positive 3. That's what the numerator looks like so far. In the denominator, I have 36. What's negative 9 times negative 1? Plus 9. So that's what I have when I take care of my I squareds. And now all that's left is combined like terms and things like that. So, who's getting together in the numerator? The i's. What's 9i plus 6i? So I got a positive 15i. And we put that second. Yep. So these two got together, and then you want to take the negative 18 and the positive 3. And what does that give us? Negative 15. And last but not least, in the denominator, what's getting together? Yep. The 36 and the 9. What does that give us? 45. Now, to get to your final answer, they want it written in standard form. Standard form looks like A plus BI. So that means what they want you to do is they want you to separate these out into the two fractions they are and reduce. So they want you to have negative 15 over 45 plus 15 over 45i. Make sure you reduce your fractions, and you're done. All we did was separate them out into their two pieces. This part right here is what we call the real. This is what we call the imaginary. Together, these make a complex number. So what is negative 15 over 45 reduced to? Negative 1 over 3, or negative 1/3. Plus, what is 15 over 45 reduced to? There you go. That's the final answer. And that, ladies and gentlemen, is your test 3.